Nice to be here. I've got bad news and good news. The bad news, I didn't get as much sleep as I'd like. And also, my day job isn't doing this. It's building a cellular infrastructure business. But the good news is the talk is about the stuff I do every day. So hopefully it will be of interest to everybody and will go well. So my background as an entrepreneur has been since I was growing up. I grew up in a very rural place, and you had to kind of create your own work, right? Whether it's finding work, delivering stone, or wood, building houses, you name it. And then in college, it was, I'd rent a tuxedo, and it was really expensive. And so I'd find a way to go get a cheap tuxedo and then realize, hey, there's a lot of other people that need these used tuxedos. And so we'd end up with a whole line of tuxedos to sell to students. And that's when I learned one of my first lessons of entrepreneurship, which was the first few we got one at a time, and then they insisted we buy a whole line that was representative of the population. And so we bought 103 tuxedos, and we sold them to the students, and we had about 25 left over, which were all the really small ones and the really big ones, because the student body wasn't representative, and we broke even. But from there, I ended up working for a big company, then a startup in Silicon Valley, went back to grad school, got involved in launching Akamai, which is a very well-known MIT success, and then launched a number of other companies. And we're going to talk about what I call pulling the string, which is that process of starting with an idea, which I would call an inspiration, right? And then iterating on that and turning it into something meaningful. And these are just a number of vignettes, right? We're not going to have time to go in anything in tremendous detail. But what I'll start out with is everyone talks about entrepreneurs being crazy when I actually look at it differently. I think the entrepreneurs are the sane ones because there's a problem. And if there's a problem and you see a solution to it, how can you not pursue it, right? That's what's in the DNA of an entrepreneur, right? That's what someone means by being passionate about something, okay? Is that you can see it, like you can see the future, and those around you just don't get it, okay? That doesn't mean you're always right, okay? But that's the driving force. And so this is one of my favorite quotes, which is the definition of insanity is to keep doing the same thing over and over and expect different results. That's what it means to not pursue when you see a problem and a solution to it, okay? That said, this is the other quote I like to use, which is, you know what, if you're a reasonable person, you try to just go with the flow and adapt to the world around you. It's the unreasonable person that tries to get the world to adapt to their ideas. That's what's so hard about entrepreneurship, okay? It's one thing for you to see the future, but you're surrounded by everyone else that doesn't see the future. Okay, and that's really hard, okay? That's I can think of stories where early on when I was building Endeca, I would show a prospective customer a demo, and they would say, I already do this. And what we did at the time was selling solutions that changed how their website would end up operating. And you could see the website, and I know provably they did not do this, right? But they say they did. I came back a year later with some of the logos of their competitors on the slide, and instead of, I already do this, it's like, oh, I need to do this because my competitors are doing it. I mean, that's just what you deal with, right? A lot of the world just follows, they go with the flow, right? So that's what makes this hard. So many people are just trying to go with the way the world is around them that it makes it really hard for those that are trying to change it, okay? And in many ways, that's what this idea that entrepreneurs are taking risk. It's the risk of getting people to actually consider your ideas is quite substantial. Let alone whether it actually works. I mean, there's technology risk, but there's just getting acceptance. So, but I would say the entrepreneurs aren't crazy. They just persevere, right? And in fact, that's what makes you successful. These are just some great stories of that. I'll let you read it. But the general idea is in the face of all this adversity, of these people just going with the flow, you have to persevere. You have to fight. Okay, and it's a battle, and you work one step at a time, and you work your way through it. I like the last one. It's hard to beat a person that never gives up, and I think that was some of what Chris was referring to in her talk. The next is we talk about these phrases, inspiration and innovation. Okay, to me, this inspiration, when someone says they have an idea, oftentimes it's that spark, okay, which starts a process. Because most ideas are born as bad ideas. In fact, one of the talks Ben Horowitz has given over at Andreessen Horowitz that I like is where he talks about the core competence of big companies. And he frames the core competency of a big company as killing bad ideas. Okay, because everyone wants to get credit for pointing out why something won't work. And so all of the ideas never make it any further. You never actually work on the bad idea to turn it into a good idea because there's all these forces working against it. Okay? Is that me making those noise? Moving my arms too much? So to me, innovation is this process of perseverance that starts out with an inspiration that might be a bad idea. I mean, it most likely has lots of bad aspects to it. Having it fully formed in all its glory is a myth, right? These things are iterated on and turned into something interesting. That's what I call pulling the string. That to me is one of the hardest parts of entrepreneurship because it's that phase where no one understands what you're talking about. It's not fully formed. It's very iterative. You have to be very imaginative. And that's where I spend most of my time working with entrepreneurs. And have done historically, although now, but it's even as a company grows, right? Depending on the nature of the business, this can continue for many years. I mean, in the company Endeca that I built, we were doing this 10 years in when we pivoted at scale. We were 100 million in revenue, and because of the global recession, we had to pivot and change the way we went about doing business, which is a continuation of this process. So, pulling the string it's the innovation, but ultimately it's company building. That's what happens as you start with an idea and you start shaping it and you feel compelled to actually turn it into something that can make it happen, right? It'd be crazy not to. If you see the solution, it's needed, right? There's a real need for it. And to me, that's this idea of perseverance meeting inspiration, right? It's having the initial idea and continuing to work at it, pulling the string, and turning that bad idea into hopefully a good idea, okay? And in fact, as you go about talking to people about your ideas, that's what you're doing, right? But you have to stay at it, right? Because it's easy to have it blow up, and many people point out for many reasons why it won't work. In fact, when I was in school, I often would describe, there was a bunch of my classmates that went on to work at McKinsey and places like that, incredibly analytical. And they were the best at killing bad ideas. They give you all the reasons why it can never work and never succeed. But it turns out, if you commit to doing something, right, ingenuity will find ways to overcome and solve some of those things, right? Because if people didn't do that, I often tell entrepreneurs, if you knew how hard it was going to be when you started, you would never do it. You have to go in with some ignorance, right? If you can see all the problems crystal clear, you would never start. Okay, and that's so in some ways, I also have a talk which I do about the importance of ignorance in entrepreneurs, right? Otherwise, they'd never do anything. So we'll start with one story here, and I'm just going to give a little bit of the Endeca story because the afternoon session goes into this in great detail. And you're probably looking at this picture wondering, what is this? And this was the sequence of events that led to the spark of inspiration that created Endeca. We had to pull a string through these various things. And for background, Endeca was started in '99. And the name Endeca, unfortunately, doesn't mean 11. It comes from the German Entdecken, which is the serendipitous meaning of discovery. Okay, so Endeca built one of the first big data databases, and it facilitated the discovery of information in a database. So one of my classmates from undergrad at Princeton was actually shopping on eBay. He wanted one of these beer cans, of all things, which were from the reunions. They had Princeton Tigers on them, and he always thought it was interesting, and he just wanted one. So he's on eBay, it's 1999, he types in Princeton, and there's thousands of results that come back. And he's scrolling through these pages, and he comes upon a Princeton Alumni Weekly magazine that's getting a ton of bids. It's like a year old, and it's selling for, it's like the MIT Alumni magazine, and I think it was selling for $50, something like that. So he goes home, finds his Post-it, sells it for like $50. And then he sees he's got an Abercrombie & Fitch catalog sitting there. And he posts that and sells it for $75 to someone in Australia, right? And when I heard about this, I was like, I want to sell everything I own at those prices. I was in grad school, right? And so I had this bottle of wine with Frank Sinatra's picture on it. I type in Sinatra, and I get thousands of results. And keep in mind, back then, because search was pretty poor, the world's changed on this, but if you typed in a precise phrase, you had this recall problem where you'd overspecify and you'd miss out on a bunch of things. So you'd always start with a simple query and try to narrow it down. In fact, a lot of eBay at the time was if someone posted something with a misspelling in it, no one would find it because it was so poor, the system. So there were some people that would specialize in finding the misspellings so they could underbid on something and win an auction because others weren't going to see it. So anyway, when I type in Sinatra wine, I get 3 identical bottles at 3 different prices. I'm like, that's not an efficient market, right? It should be one price, right? It's the same exact thing. But because it was such a mess and no one could find anything, right? And so the thought was, imagine trying to trade on the stock market, not knowing the last trade of, say, General Motors, right? It would be really, less efficient. People would just be making up prices, although they kind of do it anyway, but everyone makes it up relative to the last trade, at least. And so the idea was, well, maybe if we built a price guide of all the stuff on eBay. Turns out, we did an analysis, 80% of the items were in collector's guides. So we're like, hey, what if we had that typed in, we build this big database, 100 million items of prices, and we build a ticker for every item, and we build an efficient market. That seemed like something that needed to be built. And I'm not saying that's easy to do, because you'd have to magically figure out great AI matching technology to take the expired auction and map it with the right SKU, and that doesn't, when you're pulling a string, you don't have to have answers for everything. Right? You can set aside certain problems and keep looking and understanding the problem space. In this case, we had to solve how would you actually create the prices on an ongoing basis, but we also had the observation is that if it wasn't 3 clicks away, no one was going to use it. So imagine I've got this 100 million record database, okay, and you have to find something in it within 3 clicks. Well, search is going to dump thousands of results, right? That's the problem we had with typing in Sinatra and getting 1,000 results, or typing in Princeton and getting 1,000 results. Well, then the other option is to build a taxonomy, right? Taxonomy is a tree. So I studied applied math in undergrad, so a tree is just a 2-dimensional graph, okay? The problem is, you can't, if I give you more than 15 options on a page, or 25 options, you're going to be overwhelmed. You're never going to find anything. If you do the math, if you want to, say, have 25 options a page and be 3 levels, you have to be like, I think it was 15 levels deep. It's been a while since I've done this math. I did this math 15 years ago, 16 years ago. It's been a while. You would get like 16 levels deep, and you might have each item in 3 locations. The odds, if you assume 95% probability you make the right choice each step of the way, it's 0% that you ever get to your destination, okay? Literally, once I did that math, the observation was, I want to type in Sinatra and get a Sinatra store. I want all the Sinatra information organized in aisles and shelves as if I walked into a mall and it was perfectly organized. That was guided navigation. That's what we invented at that moment, okay? And we realized that was the problem to solve, okay? Because that was a problem everyone was going to face. And that led a path of assembling an incredibly talented team of scientists. In fact, one of the key early members of the team, our chief scientist, was an MIT alumnus that had studied operations research, did his thesis in graph theory, and computer science. And in fact, when I met him, within 15 minutes, he took the idea well beyond I could take it in 3 months, because he thinks in n dimensions, in n-dimensional graph space. Can't drive a car, but can think in n dimensions. I'm sure you all know classmates like that. So anyway, but that's how we got there. And you'll hear the rest of the story later, how that ended up becoming a $1 billion acquisition by Oracle. And I like to say we got Larry Ellison to spend $1 billion on a database. So, but you can see how we started in one place, ended up somewhere completely different. So let's see, next. So Akamai. So Akamai is interesting because it's a very famous MIT success. I was in grad school at Harvard at the time and got involved with the Akamai team. But prior to going to grad school, I was involved in a company called Inktomi on the West Coast. So Inktomi built the first parallel search engine. So when we think of Google, they were the Google before Google, okay? They were out of Berkeley. And when they initially launched their search engine, they had 5 nodes. And they had indexed all the web. And the problem was AOL represented 1/3 of the internet. And AOL cached DNS, What that meant is they had a simple load balancing algorithm called round robin across their servers, but AOL just hammered one server. It didn't work, right? The load balancing didn't work. So they went to visit AOL and learned about this, and they saw this big mess of caches and said, oh, we can do better. Independently, I was trying to get Teradata NCR to build a parallel search engine several months earlier, okay? And when they announced this, I sent them my materials because they weren't going to do it at Teradata NCR. They didn't even understand the internet at the time. And they said, why don't you join us? And it was the day I joined was the day they ran into this caching problem, and they handed it to me. And I created this concept called carrier class caching. Right? Back then, the internet, you'd have an entire countries on a couple T1 lines. So anything you could do to improve the capacity, right? And the way caching works, if I take the images on CNN and keep them local, I don't have to keep moving them over the pipe. So I create bandwidth. Now, at the time, at Inktomi, it was a software business. Now, I always envied the telecom companies because they were able to charge per bit, right? Every month, you pay for that T1. And a cache is creating capacity just like a T1 would. So when the Akamai team was starting, I got involved. They were a software company. It was called Cache. And one of the things that really helped is when we framed the problem around this phrase. A server producing bits is not different than a T1 producing bits. And that was the thing that was Danny Lewin's genius, is he figured out a way, when the problem was framed differently, to come up with a solution that is now a $2 billion business. Okay, that's part of pulling the string. Right? They started out with some great algorithms for placing cache objects. Right? And the obvious thing was to build a software business, but one was already there. If they tried to build a software business, they would have been like a little bit more efficient than Inktomi, and they never would have went anywhere. By reframing the problem, they built something that was completely different, that ultimately was much bigger and much more sustainable. So the next one. Oh, okay, it's this one. Okay. So Shoebox is a company. So one of the folks that worked with me at Endeca that I mentored, I really wanted to help him become an entrepreneur and wouldn't let him quit his job after we sold the company. I said, keep at it until we find something that you want to go do. And Shoebox was inspired by, I was meeting with an entrepreneur that was trying to build software for helping asset managers or family offices or endowments report across their assets. So the problem is, let's say the MIT endowment is in 10 hedge funds, and all 10 hedge funds are in Apple and Tesla. It's not doing much for them, right? It's not very hedged. So how do you get all that data, present it in one place? And I said, what would be really interesting is, could you also cover private companies? Because private companies, it's so hard to get the information. You kind of want the system to reach out once a quarter, pull that information, and pull it all together so you have a dashboard of what's going on. Any fund has this problem. Now, they handle it with brute force today, okay? And I figured all those angel investors and whatnot all want this information as well. But then I thought about it some more, and I was like, I would hate to be the CEO of that company that's getting bombarded with these emails every quarter asking for information, and that would be, like right now when you build a business, your investors have information rights. But because it's hard for them, it takes effort on their part to exercise them, most don't bother. So you don't have to deal with that overhead. But if you had a system, pounding on the CEO to put in information, it would be a big annoyance. So we started pulling the string on that. And eventually what we came up with was this idea, all of those documents you create when you're building a business, all the ones that end up in a shoebox, are the bane of your existence as an entrepreneur. They're really costly. You'll spend $100 grand with an attorney to generate a set of preferred financing documents. You'll have employee docs. Like when I sold my company Endeca, I was missing some inventions assignment agreements from someone we hired 7 years earlier, right? That probably was moved between 5 different file cabinets and got jammed in the back of some file cabinet and was lost. And then you have these problems trying to close your deal. They're missing. Or I had board members that were missing some documentation that wasn't signed, and that you can't do it at the moment you're selling a business because it creates tax consequences, right? What are called acceleration agreements. And so the idea behind Shoebox, what if you created the company inside a platform, like the actual legal documents, and then every subsequent action was building on that, kind of like the way you build your financials in SAP. Thus, Shoebox was born. Okay, which is going to ultimately be a company for all entrepreneurs to make their lives so much better. Starting out with United States C corporations, but it'll expand beyond that. But literally, you create an instant company, and as you go through your existence, everything gets more and more automated. Okay, so instead of a shoebox, you have your company living in its data room. But again, it was a process of iteration. It didn't start out with that, right? It started out with seeing a problem somewhere else and continuing to work at it and turning a bad idea into what we believe will be a very good idea, right? And next year, this will be very visible, this company, and hopefully you'll share that opinion. Let's see. Okay, so this company ClearBallot, and I think what Chris was saying, you can do good and do something that can be very rewarding financially. I look at what Shoebox is doing. They're going to do a lot of good for all the entrepreneurs, right? Make their lives a lot better, and hopefully it's very rewarding. In this case, this was a gentleman who was on the leadership team on the Lotus Notes project, so very successful business. So a little bit older entrepreneur, and was involved in the 2008 Obama campaign, and just thought it was madness when the election would take place that they couldn't count the ballots. They didn't know who won in many places, right? The threats of recounts and all this kind of stuff. And he's like, there's got to be a better way. So he identified a problem, okay? And oftentimes, that's the difference between, you'll notice the types of problems sort of young folks solve are their problems, right? Social networks, right? I'm trying to go find my friends, go out and drink. And then folks that have experience in other places, they identify a different sort of problems, right? Like Kiva Systems, the robots, the warehousing robots. It's because the CEO worked for Webvan in 2000 and saw the big problem, and the problem kept gnawing at him. Well, in this case, this guy's like, this is crazy. So literally, he reached out to someone that ran the Florida elections in one of the counties that was very messed up. Said, I'm coming down to sit with you. Literally just got on a plane, flew down, and said, I want to solve this problem. And he just started learning. He started pulling the string, and I don't know what his earlier ideas were because I intersected with him several years later when he had clearly diagnosed the problem and come up with a solution. This here, so it's a little hard to see at this resolution, these are ballot marks. So it turns out the reason why they can't count the elections is because people don't fill out their ballots properly. So all of you took SATs, is my guess, and if you don't fill in the circle fully, right, it's your problem if that mark wasn't counted properly. Well, if you're running for office and someone doesn't fill it out properly, it's their problem, and they're going to hire attorneys to go and manually count these. Turns out several percentage of voters, and particularly those that are really in a rush, so the important people that are voting but don't really have time for it, they're just check, 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 check. They use analog scanners, same ones the SATs use. Analog scanners shine a light through the paper, expecting the light to be blocked. Well, clearly, if someone doesn't mark like this, it doesn't block the light. Thus, these don't count. And in a close election, this is what they do. They manually start looking at each one. At least that's what happens in the US, okay? And so these guys were like, what if we use a digital scanner? Once I do a digital scanner, I could do image processing and manipulate this, right? And so they started out doing a system that would audit elections. And then as they learned more about the legacy voting equipment and how expensive and clunky and proprietary it was, they're like, hey, we could use commodity off-the-shelf parts. We got the off-the-shelf scanners. Next thing, I use an off-the-shelf touchscreen integrated with it, and bam, I have reimagined the voting systems. So another interesting pulling the string happening in Boston. And then here's the one I'm building, parallel wireless. So, you'll hear lots of things about, whether it's connecting the unconnected, 5G, all that stuff, okay? Parallel wireless is right at the center of it, okay? Which is reimagining how the cellular network is architected. Turns out, my background, my first job was at a company called NCR Teradata, and we introduced the first Intel chip into the enterprise. At the time, I was a product manager for this $500 million line of computers, really high-end. In fact, the world's largest commercial data warehouse was one of the systems built on my hardware. And it was an $80 million system, okay? It had, I think, 15,000 hard drives, 1,000 processors. It was a 10 terabyte data warehouse. Okay, today, probably most of you have that like in your video collection, okay? But in 1994, that was the biggest commercial data warehouse in the world. We introduced Intel into it, and my career has been about this intersection of Moore's law commoditizing enterprise computing and distributed computing, okay? And so I watched that unfold where for a decade people are like, oh, those Intel chips are toys. They can't handle the enterprise. And the next thing you know, it's handling mid-range. And then the big guys are like, well, it can't handle this really high-end. You know, they don't have this magic thing or that magic thing. And here we are today. All that's left is Intel. There's no digital, right? There's no, I mean, the Sun is, you know, barely there. You know, HP is barely building. I mean, they don't build any of their proprietary stuff. It's all changed. Well, in the cellular industry, there's this thing called small cells. And it started out helping people at home who have a dead spot. It'd be like a $100 device you put at home, and it kind of helps you. You know, maybe you've seen these femto cells in people's homes. They can make cell phone calls off of them. Well, that silicon follows Moore's law. And so while it starts out supporting 4 users, march forward a decade, and it's going to solve the problems that we associate with the big towers. Okay? And so the big observation here was the future of the small cell is the macro. Moore's law makes it so. What would you do given that? Turns out you can reimagine the architecture of the cell network. And our belief is we'll get the cost of building the commercial grade stuff, as good as the high end, to 1/5 to 1/6 of what it is today. Okay? That's a big step function. And make it as easy as Wi-Fi. So part of this is being inspired by Wi-Fi. Okay? And if you think about it, it's similar to what happened. If you remember a lot of the attempts to provide compute around the world. Remember the one laptop per child project, right? Which had some early success, but then once tablet computing took off, we had the model. It was a different architecture, but achieved the same goal. And so a lot of the efforts that are out there, we think this is going to be like what tablet computing did to the one laptop per child. This, just make the normal stuff so simple, and you'll get a lot more coverage and capacity around the globe. So, this is one of those other points of inspiration. This is considered a state-of-the-art cellular deployment. Or is it a grad student project? You tell me. Where else would this be considered the state-of-the-art, you know, multi-billion-dollar investment in infrastructure? I mean, seriously. It's so complex, and it doesn't need to be that way. And I don't have the time to go into the reasons why it's like that, but I can actually explain it all to you, why industry dynamics create this, not technology. Technology can clean this up, okay? So anyway, how do you foster innovation, right? Well, you need to be exposed to problems. That creates inspiration, right? You need to see something and then frame the problem a particular way. It's probably going to be a bad idea at first that has all sorts of problems with it, right? I mean, oftentimes when these are what stupid questions are. I'll ask a stupid question, and people look at me funny, and then they figure out, okay, if we just change that just a little bit, actually it's solvable, and it turns out it's a good question, right? So that can be an asset. If you draw on diverse expertise, right, you build that network and you talk to people with different backgrounds, it doesn't seem so unreasonable. We started talking about that unreasonable person trying to change. You know what? I look at what I'm bringing to cellular as my expertise in enterprise computing. And I find just perfect analogies that help me forecast how it's going to unfold, okay? And then this last one, intellectual curiosity. You got to love the process even more than the destination. You got to love learning. You got to love pulling the string. You got to love just learning more and more to where you can figure out how to make it work. Now, that's a certain class of business that's like that. There are other businesses, right? You could be in a commodities business, you know, drilling for oil, which probably isn't about intellectual curiosity. That's just grit and keep, you know, drilling till you find something. But the innovation, you know, kind of the innovation economy is about intellectual curiosity for the most part. And, you know, mentors can help make it contagious. Those are people that are exposed to other areas that help you make it further along, right? And they're an essential ingredient to that perseverance, right? Because they help you overcome obstacles. They help you just incrementally improve that bad idea into a good idea. So that's what I got. And I look forward to speaking with more of you later this afternoon.